Unfortunately, I cannot save screen recording because the graphics card of this computer, which is very old, is not supported by screen recording program. So I just put my mobile phone over a platform, so you can both see the hardware and the screen. In the experiment, we can arrange the controller gain values KP, KI, and KD by setting these numbers here. So we can start with some predetermined gain values. The set point is 0.5, which is at the center of the vertical distance, the vertical position. Now we can start. It may take a little bit time. Now, as you can see, the ball is in the air. Now we can start the experiment. Here you can control the controller gain values KP, KI, KD, which corresponds to proportional, integrator, and derivative gain values. Now we can start the experiment. Firstly, as you can see, the red circle, the set point is adjusted as 0.5, which is at the center of the vertical position. Now let's run the experiment. The KP value is 2.5, KI is 3.5, and KD is 0.025. Now let's start. It may take a little bit time. Now you can see the ball is elevated. Now it is floating in the air. No force except electromagnetic force. Now let's change the set point. For example, I will decrease it. You see, the ball is also decreased. Now let's increase it. It's like a magic, right? Very interesting. Let's increase a little bit more. What happens? I just decreased it. I just made it 0. Wow, it's very funny. You should come and play with this one. Maybe at the end of this outbreak, you can visit the lab. Maybe I can show you. Very nice. Oh, very funny. Okay. Now let's see the effects of the controller gains. What happens? I will to change these gain values. I must stop the experiment now. I should again arrange the ball to its place. Actually, maybe I didn't show you. I can fix the ball's position by this thing. I just insert the ball over this one and it stays where it is. Now I'll put this ball at the center over the sensor. Now, okay. Now this time, let's see what happens. I decrease the KP value to 1, KI value to, for example, 1. What happens? Let's make the set point 0.5. Let's run it. You see, there's a little bit more overshoot. Let's try another value, for example 0.1. Ki is decreased to 0.1. What happens? Nothing happens. So it just rose very late. So what's, I didn't understand. Let's try it again. It increased. It is elevated very late. Now let's examine the effects of the game values. For example, let's start with no integrator value 0, Ki is 0 and Kp is 1. Let's even make the Kd 0, just Kp. Let's run it. What happens? There was a very little position change, but it is not enough to elevate the ball. Okay, let's stop it. For example, let's this time make the Kp value 5. Let's run it. Too much vibration, too much overshoot. It is very strong. Even it just put out this. Okay, let's start again. This time let's try 2, for example Kp value. What happens? Ki and Kd is 0. As you can guess, there are overshoots, but it is less than Kp5. Okay, again let's now introduce some derivative value. 0. For example 0.01. Okay, let's run it. Nice, smooth. However, as you can see, there is a steady state error, so it cannot reach to the set point. So what happens as I increase the derivative value to its 2-3 times of the previous value. Let's run it again. I think it has a better performance, but again there is steady state error. So what should have we done to eliminate the steady state error? As you can say, we should introduce some integrator controller value. Why? Because integrator has some memory and it eliminates the steady state error. Now let's just insert 1 for Ki and observe what happens. Oh, so it smoothly increases, no overshoot, but I think it is still a little bit slow. So maybe we can increase the gain value of the integrator for a better performance, maybe 5. Let's insert it again, it's the ball to its place, and KP is 2, KI is 5, and KD is 0.03. Let's run it. Oh, here is little bit, very little overshoot, but it's much better in terms of performance compared to the previous one. For example, let's make the integrator value 10. What happens then? I should have put it to the center. Okay, let's run the experiment. Better. So what happens if I make the KI 20? Let's run it again. Oh, it is much stronger, much harsher. Okay, I am looking for some excitement. Let's make this KP value 5. You see, there is a very big overshoot, even such that it came very close to the top point. We analyzed the effect of KP and KI, where KP introduces some oscillations if it is increased too much. KI also decreases the steady state error, and if we increase it still too much, it can also produce some oscillations. But we didn't analyze, we couldn't observe clearly the effect of KD value. Now first let's make KD 0, KP 3, KI 5. Let's run it. Wow, too much vibration, so it just decrease the oscillations. For example, this time let's make 0.05. You see, this time it is a little bit slow. Let's make more experiments. KP is 2, KI is 5, KD is 0.025. Let's run it. Now let's decrease the KP to 1. Some overshoots. Let's decrease KI to 3. Less oscillations. Let's make KI 1. Very less overshoots, but it is delaying the response. Now let's make it 2. there are some overshoots. This time let's increase gain value to 0.04. The overshoot is increased, decreased, but there may be some problems. Let's make it this time KD 0.05. Yes. What happens if we increase further? Let's make 0.075. Not very stable. It is stable, but it is oscillatory. Okay, let's make it 0.01. What happens? Very sharp response. 0.005. First overshoot is very increased, so the derivative gain has some milding effects on the response of the system. That's all for today. We played with the magnetic levitation hardware. It was very funny. I hope you also enjoyed. I will post the homework with the experimental document. So also you are going to prepare a short report. This will be the lab report of this experiment. Again, I should say the homework and the report is the lab report of the experiment. Thanks for watching. I hope you enjoy your time, and I hope to see you here after this outbreak, and you can try this experimental setups. Thanks for watching. See you.